Welcome. In this video, I'm going to continue an example of a classic related rates problem. So we have a 10-foot ladder leaning up against a wall. The ladder is sliding down the wall. If the top of the ladder slides down the wall at a rate of 1 foot per second, how fast is the bottom moving along the ground when the ladder is 5 feet from the wall? So as always, let's begin with a sketch. Now here's the sketch. The ladder here has a length of 10 feet, and we're told that it's sliding down. It is in this direction at a rate of 1 foot per second. And I left some important detail off, that is, this is a right triangle. So how fast is the bottom moving along the ground? This is our goal. How fast is the bottom moving along the ground when the ladder is 5 feet from the wall? So when this distance here is 5 feet. So our goal, that is, we want to find this rate of change. So we want to find the change in x with respect to time. So we're going to find dx over dt given, and the information that we're given is at this point the ladder is 5 feet from the wall, so x equals 5. Again, the first thing we need to do is relate these quantities. So let's start with the Pythagorean theorem. X squared plus y squared equals 100. Since the hypotenuse of this triangle is 10, this is where this 100 comes from. And now I need to find the derivative of both sides with respect to t. So I need d over dt of x squared plus y squared equals d over dt of 100. On the left side, I end up with 2x dx over dt plus 2y dy over dt, and this equals 0. Now my goal is dx over dt, so I'm going to rewrite this. And I'm going to rewrite this and solve for dx over dt. That is, I'm going to get this by itself, almost like you would in a normal basic algebra class. If you had 3x plus 2 equals 0, you want to get x by itself. In our case, we want to get dx over dt by itself. So 2x dx over dt is equal to negative 2y dy over dt. This tells us that dx over dt is just equal to negative 2y over 2x dy over dt. Now, of course, we have a common factor of 2 in our numerator and our denominator. 2 divided by 2 is 1. So I can just rewrite this as negative y over x. Now let's fill in what we know. We were given dy over dt here. So dy over dt, and this is where you need to be careful. So let's look at our picture. The y-axis, is the wall. And as you travel from up high on the y-axis towards 0, you're traveling in the negative direction. So our rate of change here, that is dy over dt, is negative 1 foot per second. And now we already know that x equals 5, and we need to find what y is. Well, we can just use the Pythagorean theorem for that again. That is, and I'm going to do that up in this corner here. That is x squared plus y squared equals L squared. In our case, x is 5, so this is 25 plus y squared equals 100. So y squared is equal to 75. From this, I know that y is equal to root 75, which is just 5 root 3. So now we can fill in all of our blanks. So I'll do that over here. Dx over dt is equal to negative y. Y is 5 over root 3. So y is here. Now let's continue. In the denominator, we need our x, and our x value is just 5. And now finally, I need dy over dt, and dy over dt is -1. So again, this is in feet, times -1 feet per second. This simplifies to just √3 feet per second. Now, clearly, none of us would speak to another person this way. We wouldn't say, oh, this ladder is moving at a rate of √3 feet per second. None of us talk like that. And I clearly don't make that voice all the time I talk. So let's go back and let's just quickly rewrite this. So √3 is approximately 1.7. So if I were to communicate this to someone, I would say the bottom of the ladder is moving along the ground at a rate of 1.7 feet per second. I hope you found this video useful.